So hey guys, welcome to Topics Math Class 10 100%. This is Siddharth, and today is our first video, and we are going to learn about chemical equations and reactions, part 1, which is chemical reactions and describing a chemical equation. Let's start. Chemical reactions and equations. What is a chemical reaction? A chemical reaction is the transformation of a chemical substance into a new chemical substance by making and breaking of bonds between different atoms, which is known as a chemical reaction. So, if we take an example of hydrogen and oxygen, and we combine the hydrogen and oxygen, which are both gases, we get a liquid, which is a totally new substance, which is H2O, commonly known as water. There are two parts of a chemical reaction. In a chemical equation, we have a reactant side and a product side. In the reactant side, the substances which are destroyed by the chemical change is kept, and in the product side, the new substances which are formed is written on the product side, and there is an arrow which makes the partition between the reactant side and the product side. And the arrow means it yields or it gives out this particular product. Now coming to the symbols which are kept in chemical reactions. The first symbol is S, which refers to solid. If the compound or molecule is solid, we write an S beside it. And if it's an L, it's a liquid, and G as a gas. And if it's AQ, it is known as an aqueous solution. An aqueous solution comes when a substance is dissolved in H2O, which is water. For example, if we take um, sodium and dissolve it in water, you get NaOH. I'll just write the chemical equation. So if we combine sodium with H2O, we get NaOH. Sorry. So we get as NaOH. Um, and this NaOH is in a solution form. That's why it's called as an aqueous solution, and it has to be written as AQ beside it. And if you can see in the reaction, I've written Na plus H2O, which gives the NaOH. You can uh, you can get to know that there is a plus which is written, and this plus indicates that this a particular element or a compound or a molecule is combined with another compound or molecule. So the two compounds or molecules are separated by a plus in the reactants and even in the products. Next, coming to word equations. The statements that indicate the reactants and products in a chemical reaction is called as word equations. And for example, if we combine iron and chlorine, which gives you iron chloride, and in a word equation, it's known as solid iron and chlorine gas react or combine to produce a solid iron chloride. So as you can see here, this is an S, which is a solid, and G, which represents gas. Combine it, and you get iron chloride. Uh, as it is iron 3, as you all know, iron 3 means ferric, and iron 2 gives ferrous. Next, coming to translating word equations into skeleton equations. So basically, we learnt about word equations. A skeleton equation means an equation which is represented with the symbols representing the element or the compound. For example, here we can see iron. Iron is represented as Fe and chlorine as Cl2. So if we combine it, Fe plus Cl2, which gives us FeCl3. Now it is known as FeCl3, and this is known as the skeleton equation. Next, and during a chemical reaction or an equation, we can see that if you take any kind of reaction, there is a conservation of mass. That means that none of the mass of any element is destroyed nor is created. And by our great scientist called Lavoisier, and he told that no, I mean, any element can't gain any mass nor lose any mass during a chemical reaction or a chemical change. As for example, we can see here hydrogen and oxygen gas react to form water, and so we can see H2 plus H2 will give you H2O. So the same number of atoms in the reactant side of hydrogen is same in the product side, as you can see H2 here and H2 again here. And O2 here, which is two atoms, at now we should just balance it by writing 2 here and 2 here, because even hydrogen should get balanced. 2 into 2, which is 4, and again 2 into 2, which is 4. And 2O will give you O2 and O2 here. So this reaction is balanced. And coming to balancing of equations, it will be in our next session. And then this is conservation of mass. Uh, Now, coming to describing a chemical reaction, the first thing we can see is there's an evolution of heat or light or sound during any kind of chemical reactions. Next is there's a production of gas, there's a release of gas like hydrogen or oxygen. Then there's the formation of any precipitate. And the fourth one is there's a color change. So any one of these or any two of these can happen during any chemical reaction. Yes. Next, change in state. For example, you can see NH3 and HCl. So we can tell that right by writing NH3 here plus HCl will give you NH4Cl. So we all know NH3 is ammonia and HCl is hydrochloric acid. And whereas in this reaction we have gas, a hydrochloric gas, and then if we combine it, we get ammonium chloride, which is a solid. So here we can see that the change in state is, if we see here, ammonia is a gas, hydrochloric is a gas, then we get a solid. So we can see that when we have combined two gases to get a solid. So therefore we can say that there's a change in the state of the compounds and elements during this chemical reaction. Next, coming to change in color. This is one example. And if you have ever seen, or if you have a lab kit at your home or in the school when your teacher has shown you, we can see that CuSO4, which is basically copper sulfate, when it's combined by iron, which is Fe, which gives FeSO4 and copper. We can see that, as you can see in this picture, we can see the iron nail, which when is put to a blue copper sulfate solution, we all know that copper sulfate is also known as the blue vitriol. And so when an iron nail, which is made up of iron, and is put to a copper sulfate solution, we can see that after some time it changes. The it displaces by making the solution turn green, and the iron nail giving a covering of copper metal. So by this we can see that there's a change in color of the solution during this particular chemical reaction. The next one is evolution of gas. If we take this equation, Zn plus H2SO4 will give you ZnSO4 plus H2. As you can see, this is in the picture. This is an experiment which can be done in the chemistry lab. You take a flat bottom flask and put dilute sulfuric acid into it. Then put a few zinc granules. So then zinc reacts with H2SO4 with the sulfuric acid in the uh, in the conical flask, and then put a cork to it and put a slight glass tube piercing through the cork. Then in a few minutes you can see that you slightly hear a pop sound, or if bring a matchstick near it, and the matchstick starts to light. So by this we can say that hydrogen gas is evolving, and it is uh, the hydrogen gas is evolved and it's coming out through the glass rod. As we know, hydrogen is a flammable substance, so it lights the coke. I mean, it lights the matchstick, and therefore we can say that hydrogen gas is involved and it's evolved in this particular chemical reaction. So the next one is change in temperature. There will be a change of temperature when you convert NH3 plus H2SO4. As you can see here, during this time, you can see in this diagram here, this is the mixture of NH3 gas plus H2SO4. Here, usually if you touch any liquid in a conical flask, it usually be, it will be at room temperature and, cold. But this solution turns immediately when they mix NH3 and H2SO4, you get a lot of bubbles coming out and a lot of gas coming out. Uh, so this, from this you can say that if there's a change in temperature, so the temperature is increasing from when it was before at room temperature when this reaction is done. Okay, so next going to the formation of precipitate. A very well known example which is BaCl2 plus NH2SO4. BaCl2 is barium chloride, as we all know, and Na2SO4 is sodium sulfate, which gives you BaSO4, which is barium sulfate plus 2NaCl, which is sodium chloride. Here we can see that, as you can see in this diagram, when we mix BaCl and Na2SO4, which both are aqueous solutions, when we mix them, we get immediately a white PPT. PPT here stands for precipitate, and it fully settles down at the bottom of the test tube, and that is called as the barium sulfate. That's why one of the products is barium sulfate, and the solution becomes NaCl, which is an aqueous solution form. So this blue here is NaCl2, and this is the barium sulfate. One minute. Yeah. So this is barium sulfate, which is the PPT of this reaction. PPT means precipitate. So this is it for today. I hope you have learned a lot in this from this video. This is the part one of chemical reactions and equations. In the next class, we'll be learning how to balance chemical equations and reactions, which is very an important part of this chapter. So please, please subscribe and like this channel and like this video and share this video with whomever you